Coastal erosion in Nova Scotia. So first, what is erosion for those of us who don't know, although I suspect all of you know a lot more about erosion than I do. So erosion is the removal of rock, soil, and other materials from one location to another. This can happen in several different ways: water, wind, glacial activity, and human activity. We actually are increasing the rate of erosion in certain parts of the world. Erosion and then deposition, so when this material is dropped off somewhere else, are natural processes that shape and create landforms. Coastal erosion is the loss or movement of coastlines. Several factors can affect how much coastline is lost at any point in time. It's constantly occurring, and it is a natural phenomenon, but sea level rise from climate change is increasing coastal erosion and changing our coasts at a very quick rate, faster than it might be if perhaps humans were not here. There's different types of coastal erosion. So we'll talk about abrasion, which is when loose material is hurled at the cliffs via wave action. This is something that occurs quite frequently in the Bay of Fundy, which has the strongest and highest tides in the world. Um, there's attrition, where waves move loose material around, breaking them down further. This is something that if you happen to have visited the Joggins Fossil Cliffs, or if it's on your bucket list, you will see that at the beach. You will see worn down bricks and worn down rocks that are quite weathered from the waves, moving the material around and smoothing them out. There's also hydraulic action, where air in cracks are released when hit by the waves, causing further fractures, which causes the material to become looser and then eventually be lost to the sea. This can also occur with freezing, which is something that we are very cognizant of here in Nova Scotia because of that freeze thaw cycle that we have started to experience with climate change. There's also solution or corrosion, where water reacts with certain rock types, causing rocks to break down. This commonly occurs with chalk or limestone, like in the famous Cliffs of Dover over across the pond in the UK. Coastlines are dynamic, though. Changing sea levels is a factor. Rising and sinking coastlines are also factors. Coastlines change globally and
Mom,
locally over
mom,
time.
mom.
Some changes occur over long periods of time, and some, as we are going to learn today, occur incredibly quickly. What do I mean by over long periods of time? Well, you can see here, this is a map of what Mi'kmaq or Nova Scotia, Atlantic Canada would have looked like during close to the last glaciation. Like we're in an interglacial period now, and you can see that Prince Edward Island and Nova Scotia are connected. That is something that we know, like that Mi'kmaq know that we know because when you talk about where I'm from, which is around here, Piktook, we talk about Piktook and Prince Edward Island as one. And that's because at one point they were one. They were one landmass. It can also happen over longer periods of time. So this was a study using old photographs at the Tignish Provincial Park, where you can see that between 1939 and 2005, one portion of the park has lost quite a bit of land compared to the rest of the park. There are various reasons for that. Um, but yeah, that one section has lost quite a bit of land. And it can happen quite quickly. This is Cape John. And as you can see, within, from pre-hurricane to post-hurricane, so within 5 days, you can see quite a bit of land loss. All of these boulders were shunted around because the waves were so strong. And this beach access point here, these stairs are now gone. Why is that so important? Why does that matter? Well, it matters a lot to Nova Scotians. We have a lot of coastline. We're bordered by different bodies of water, the Gulf of St. Lawrence, the Northumberland Strait, here, the Bay of Fundy, and then the Atlantic Ocean. A huge portion of our population lives near the coastline, around 70%. And many industries here in Nova Scotia are directly or indirectly rely on the ocean and therefore the coast. The average coastline loss each year can be as little as centimeters or as much as meters in some places. The changes to the coast affect the welfare of Nova Scotians, from flooding, erosion, plant and animal distribution, to destruction of infrastructure that we rely on to move around the province and to access goods and services and everything else that we might need. It also affects the tourism industry quite negatively. Nova Scotia welcomes more than 2 million people each year. Most, 65%, drive from New Brunswick into Nova Scotia via that Chignecto Isthmus that has been a topic of discussion lately because it is our only link to the rest of Canada and Turtle Island. The annual revenue for the tourism industry is $3 billion. That is a lot of money that, we might lose some of that if we become more difficult to access with rising sea levels and changing coastlines. So, in Cumberland County, which is where the Joggins Fossil Cliffs are located, there have been efforts to monitor erosion and uh, in order to come up with an action plan to help preserve our coasts and to stay connected to the rest of Canada. So, this is Cumberland County outlined here. The Joggins Fossil Cliffs are here. We have the Northumberland shore, which is where I'm from, up along here. And then we have the Bay of Fundy portion, which has the Joggins Fossil Cliffs, and then the Cliffs of Fundy Geopark, which actually extends into Colchester County too. The Bay of Fundy has its own unique challenges. They so like I said, we have the highest, strongest tides in the world. Around the world, the average difference between low tide and high tide, that vertical difference, is 1 meter. At the Bay of Fundy, it can be up to 15 meters, and often during particular times in the lunar cycle, specifically at the Joggins Fossil Cliffs, it can be 13 meters. And low, it might be 9. Horizontally, that means that you get, kilometers of beach exposed at low tide. And when it comes in fast with the force of a Category 3 hurricane. So when that is amplified by an actual Category 3 hurricane, you can see why we start to lose a lot of land and why it can be an issue. Here is that difference specifically at the Joggins Fossil Cliffs. So I took these photos over the summer. You can see at low tide at 9:12 a.m. You would have a lovely time walking the beach, and then a 12.2 tide on a not so windy day at 3:07 p.m. There's no beach. You might as well be a seal out there swimming around, watching the cliffs. And in fact, that is when seals come to visit us at the Joggins Fossil Cliffs. So at high tide, when there's no people on the beach, we will see seals bobbing along. They also enjoy fossils, I hear. Along the Northumberland shore, they have set up tidal measurements. So prior to 2023, the nearest tidal measurements to us were taken in my home, Pictou County and Shediac. They are 200 kilometers apart if you're driving that Highway 6 along the coast. But now they have added a monitoring station in Northport to produce a coastal flood vulnerability map. This measures tides and storm surges every 15 minutes, and these measurements will help them to predict coastal vulnerability. At the Joggins Fossil Cliffs, we're looking to do more frequent monitoring via drone, and we are doing comparisons between historical and recent photographs, trying to line them up to try to calculate how much coastline has been lost that way. Other sites in the Cliffs of Fundy Geopark, which is our UNESCO sister site, their UNESCO Geopark, they are participating too. And this is a good example of participatory science. So this map of Coal Miner Point was done in 2003 by a local George Karma. Coal Miner Point is really important to us at the Joggins Fossil Cliffs because we found a lot of really special fossils there, including Hylonomus lyelli, the oldest known reptile, Dendrifferton, the oldest member of a group that contains frogs and salamanders. So there are a lot of really important historical fossils found there. So, and it because it is a point, it is more likely to be hit by those tides and weather away. So, what do we mean by kind of comparing those photos? So, and what does it mean kind of for locals? So, we're not just worried about the fossils, we're also worried about the people living along our coast here. So, this home was here in 2012. And by 2023, you can see that here, that home had been lost to the bay. So that's somebody's family home where they grew up in that home. They would play in the backyard with their siblings growing up. And then in their lifetime, they went from being able to play in their backyard to not having a historical family home in an area that is already quite impoverished. That's devastating. You can't afford to sell no one wants your house. You can't afford to stay in your house, but you also can't afford to move. And that inequity is something that we care quite deeply about at the Joggins Fossil Cliffs and why we want to monitor them and protect them, not just for the fossils, but also because at the end of the day, the human life is much more important. I'm not sure if I should say that as a curator, but it's correct. And it should be said that as the human life and the human use is more important to me, and that people are not forced out of a place where they have lived for generations. You can see there. There's also future research. So we've been partnering with provincial geologists. This is a photo from Mitch Miracle, the coastal geologist with the province. So he'll be coming up with students to monitor the Joggins Fossil Cliffs and I believe other sites around Cumberland County. We're also always looking for old photographs. So if anyone here has old photographs of the cliffs, preferably with the location and information in the year, please send them to us because they are really useful for lining up with today's photos and seeing just how much coastline has fallen away.
This is a personal uh, view, and I'll explain further. Cape Breton is in the north part of Nova Scotia, and one of the things I'm not an expert on this. I'm a general geologist, more worried about volcanoes and ore deposits, but I'm very curious, and I have a grandfather who was born in Venice. And here you can see to the left, you can see the number of times tides have been over 1 meter, which means it floods the St. Marcus Square. And I've been 3 times in Venice. I know the place where my grandfather was born. In those days, they didn't have this sort of problems. And why do I do this? I'm concerned about the general lack of concern. I think that people are hoping that this is going away. Uh, The purpose is to promote field observations, detailed studies, students' involvement, and better than me are many experts in the region about flooding and erosion, departments of oceanography, earth sciences, geology, environment, the Bedford Institute of Oceanography, the GSC, Nova Scotia Environment and Climate Change, the Department of Natural Resources and Renewables, and the Ecology Action Center, and many other groups that are concerned. And I want to thank first to Peter Finch and Gundi Viviani Finch, who live in Little Lorraine in northern Cape Breton, and because they invited us to visit the area and they took us for a walk twice, and this is what I'm going to talk about. And also, I want to thank Jean Richardson and her partner Bob Davy from University of Waterloo. Um, Jean was a student of mine for a couple of years, I think, a long time ago. Anyway, eh, hurricanes have been damaging. I remember one in 2003. This is Peggy's Cove, tourist attraction. Peggy's Cove has only been, the town is accessed in the west. The waves came from the east and came over 7 meters over this part of land, over 400 meters, and made a lot of damage at that time. In Halifax, I remember that is considered the worst storm to hit Halifax since 1893. And in this part of downtown, there was water up to up above the knees and waist in many places. The waves at a buoy in the harbor indicated that the waves of 10 meters, not breakers, but waves. And in another buoy outside the harbor, it was 20 meters. So I wonder, what is this? Where did the people come with the conclusion to spend $137 million of taxpayers in this place in an art gallery, when the art gallery is the most vulnerable to humidity and so on? So I know that it has been stopped, but it makes me scratch my head. And this is what I mean. Lots of people should know better. Okay, Hurricane Fiona hit Nova Scotia in September 2022, and according to Environment Canada, was the strongest recorded storm to ever impact Canada, with winds of 170 kilometers an hour. Very little will withstand that kind of attack. It's the costliest natural disaster in Atlantic Canada's history from the insurance companies. And I will indicate something that I saw. So Fiona also devastated Newfoundland, Porto Basque. There were deaths there, and it destroyed a long time fishing village, um, which had been there for hundreds of years, and you can see the devastation and the destruction of many homes. Anyway, Fiona came from the Caribbean, went like this, and then attacked Louisburg there at about from the south directly, and then continued to Newfoundland and where I mentioned Porto Basque. And Gooseberry Cove is right here, and we were invited to visit this area by Peter Finch and Gundi Viviani. In 2001, we went to a beautiful stroll along a trail there and revisited in 2024. And Gooseberry Cove is on a headland, and was directly hit from the south. There's a nice trailhead there you can access from the car. So this is Gooseberry Cove. That's Little Lorraine, where Peter Finch and Gundy live. This is the fortress of Louisburg, the French fort until the English took over the British took over the land of this part of the world. Um, it's a nice place, and it's a very exposed coast, you can see, but most of the population has gone into uh, Little Lorraine, or they're behind some in bays. Well, in Little Lorraine, in the Gooseberry Cove, the trail is destroyed, most of it. The destruction is amazing. I had heard about destruction of trees and so on in Halifax and in other places, but this was quite a remarkable thing to see. This is more than you normally expect from a storm. This is in 2021. This is Gundi, and she took us here on this beautiful trail along the coast. It is rocky, but it is not what it is today. The whole vegetation in the big swath of the coast has been removed completely, erased. You can see here that sometimes if you measure the distance from here to high level, it's about 12 meters. It's not just 2 meters, how people have talking about the increase of sea level change or whatever. This is 12 meters above sea level. It's not only vegetation that was erased. You can see that there's 2, 3 meters of gravel and sand that were stripped out of the coast here and taken who knows where. This one is one part where the waves got to 12 meters above sea level in this place, and you can see how it stripped completely all of this region here. There is nothing left of the vegetation or the soil. And it exposes, as I mentioned, it exposes like fresh rock, which hasn't been there for 10,000 years probably. It moved huge boulders, blocks the size of a small smart car. Um, it just jumbled them all over the place, and you can see that this is a wave action associated to that enormous wind. The pieces of rock come from who knows where. These are rocks and not local rocks. They have been displaced from another part of the outcrop. And the vegetation is just stripped out for hundreds of meters out from the coast. And it's not the vegetation, where did it go? And Jean Richardson, who went there after us and saw my presentation that I had proposed, and she said, wow, we were there. And he says it was amazing how the vegetation was rolled up. Says it looks like a giant carpet. And you can see here the vegetation has been taken out, the soil and the peat. The the rocks are white because the acidity of this peat and soil has bleached the rocks into white. So it's very, very dramatic. The other part that I find very, very important is that the local forest was uprooted and downed for more than 1 kilometer inland. Jumbled, dead trees and dry, they are really a very dangerous fire hazard. You can see that is what the forest looks like around there. I wish I remember traveling, doing geology in forested areas, I wouldn't like to have to go through this area. There is no way you can go through a forest that is destroyed. The trees have been uprooted and dead. And this on the left here is the Gooseberry Cove here, Herring Cove. This is the trailhead. You can get this distance here is 500 meters. This is 2018. You can see the green forest and the green vegetation down to the coast. The same area from Google Earth, you can see that all that vegetation is gone and all the forest is brown, is dead, jumbled forest with tangled trees that there's nothing left. Here we have in 2021 at the bottom, we have the healthy forest and the beach. Today, the forest is completely dead. And I insist it's really dangerous because this is an area where we have possibility of forest fires, and that would be very devastating. What can be done? And one of my former students, Phil Fink, from the Report of Activities in 2007, has a nice volume, about 15 pages, explaining what can be done to protect and has been done to protect the coast. Wooden protections don't work. Some of them can be done to work. And there is a lot of expertise, local expertise. There is no excuse for us to be doing foolish things. This is Purcell's Cove, where I lived for 26 years until recently. The neighbors have had problems with the coast. The first one here, this family here, lost all their sewage system, and they built a wall of 2 meters after one of the storms, and it's failed twice. This fellow here built a big mansion, and it has it's 3 to 4 meters high. Yet the last time I saw it, it had been flooded too. The neighbor, a new neighbor there, seems to be aware of how things are going and is building a 10-meter wall where on top of that he's going to build his house here on the left. And I read that King's Wharf, which is a big development in Dartmouth, the lowest floors are 8 meters above high tide, not 2.5 meters as the regulations say it should be. So there is there's lots of information from the Department of Natural Resources, Environment, and there is no excuse for people to be. These stone walls here, armored stone, cost a fortune. I figured out for one property, each one of those boulders installed cost $150. You can imagine how much it costs to protect your coast. But that's not sufficient if we have higher waves in the future. Now the good news. We always worry about seeing the real rocks, and vegetation is not very helpful. We have to dig trenches to find the geology sometimes. Precambrian geology in this region is beautifully exposed. They're volcanic sedimentary rocks at about 575 million years. It is a very good place to look at rocks, and the vegetation is coming back. This is the geology from Sandra Barr and Chris White and others. This is the region here, is the Menadieu group. Again, 575, they're granites. This area is full of volcanic rocks and volcanic sedimentary rocks. Uh, the the exposures are fantastic. As I say, they have been bleached, so they're perfect. You can see all the textures of the rocks and all the structures beautifully exposed for hundreds of meters from the coast, which is not the normally you can see only the cliff, but here you can see a huge swath of very perfectly exposed geology. And here we see some volcanic sedimentary. They're a little bit, you can see these are volcanic clastics brought from an eroding mountain chain with volcanoes probably. And they're kind of flattened because the rocks are metamorphosed. That means they have been affected by heat and pressure. So they're not perfect as they were, but you can still see their composition and you can tell a lot about their rocks. This is a photo from Gene Richardson. I'm very grateful. They're basalts, they're andesites, they're most of it is ash that has been then turned into very, very hard rock. The good things is that vegetation is coming back slowly, but it's there. In a few years, there's going to be again grass in there, depending if there are no more surges or waves hitting that part of the coast in the next few years. So what I want to say is the coast is vulnerable to more than 12 meters above high tide, and it can be affected inland to 150 meters and more, that no building would have survived the energy of the sea and the wind. And in Gooseberry Cove, Wild Cove, Louisburg, and many trails on the coast, the surge damage was directly from the south, and it hit them very, very badly. Peter Finch says, well, in deeper coves like Louisburg Harbor, Big Lorraine, Little Lorraine, and Baleine had sea swells of only 2 or 3 meters. And in these locations, no houses were inundated or swept away by the surge, but many houses did sustain damage to roofs and siding. So it's mainly along the exposed parts of the coast. The forest was uprooted and dead for more than 1 kilometer inland, and now there is serious fire hazard that should be considered. Now, there is expertise in the region. There are publications from the Nova Scotia Department of Environment and Climate Change, where they explain what to do, the coastal hazard map. There are all kinds of information. Consult your local expertise, implement a coastal protection plan that has passed by legislation in the province, but not totally approved. Adapt because we have nothing we can do. Things are changing. We have to adapt. And the good thing for my colleagues and friends and students is that there are lots of good places for student thesis projects and field trips. This is there are many publications on these days. This is Bernier et al. 2024 on journal Weather and Climate Extremes, and talks about storm surges. What can we do and must do? First of all, there has to be effort in forecasting. The oceanographers have buoys and all kinds of information from satellite. We have to know, we have early warning to protect the coast. We have to produce inundation mapping of the coast. The Nova Scotia has a pretty good inundation map about floods and coastal inundation, and people have to pay attention to that. Then there's coastal protection. You can build barriers and protect some of them, or big walls to protect the area from flooding. That is possible. But to a great point, you have to relocate homes and vulnerable constructions away from where they're going to be destroyed. If anything hits them, like in Gooseberry Cove, they're all gone, you know. And then this paper emphasizes that you have to have planning for evacuation. These things happen in a matter of hours, and then it's a matter of minutes, and they affect small areas with great energy. So thank you for listening to me here. Jade Atkins, director of the Joggins Fossil Institute. Thank you for inviting me. Peter Finch from Little Lorraine. He works for the Cape Breton Food Hub and is author of a very nice little book about his experience in Ontario. It's called The High Up in the Rolling Hills, available from Amazon. And Gundi Viviani in her beautiful home in Little Lorraine produces fantastic glass sculptures. So thank you to them. And also thank you to Jean Richardson and Bob Davey, who provided photos, and to my wife, Armgad, who supported me and went with me to the field. Thank you very much. If anybody has questions, this is my email, Zentilli@dalhousie.